let's get back to it. Type synonyms is what we're learning about today, I guess. Haskell. Previously, we mentioned that when writing types, the list of characters and the string types are equivalent and interchangeable. Yeah, they're the same. That's implemented with type synonyms. Right, type synonyms don't really do anything per se, they're just about giving some types different names so they make more sense to someone reading our code and documentation. Here's how the standard library defines string as a synonym for a list of chars. This I don't like. As someone being terrible at names, why do we have to have two names? I mean, it makes sense for the string, right? Because we all know what a string is, and we know that it is a list of characters, but wouldn't life be just easier if we just called it a list of characters? Right? Especially now, because what this chapter is going to be about, or this part is going to be about, is making our own type synonyms, and that's just, oh man, that sounds awful. Solburn said that COBOL is a mainframe language. Many banks still use it because of legacy code. There we go. Oh, right. It's important to keep those up and running. Volgetinotab says, fun fact, perse is Finnish for ass. Wait. Bottom, not donkey. Wait. Perse? How did we get to that? How's that relevant to what we're talking about? I don't remember. Okay, we have introduced the type keyword. The keyword might be misleading to some because we're not actually making anything new. Yeah. We did that with the data keyword, yeah. But we're making a synonym for an existing type. If we make a function that converts a string to uppercase and call it to upper string or something, we can give it a type declaration, right? To upper string, exactly. Get a list of chars to a list of chars. Or we can say to upper string and we take a string and we get a string. Both of these are essentially the same. Only latter is nicer to read. I don't like this as a... No, I don't like it. I see why we do it. But no. Kolyatinotep says type synonyms don't really do anything per se, which is very weird. Why would you have something that doesn't do anything in a functional language? I thought we did a functional language, so we do something that doesn't really do anything. That doesn't sound functional at all. Types does not have a function because it makes things shorter. Oh, right. It's like when we import modules, right? And we just give them a capitalized letter, so we can just do like, I don't know. Let's say we had to do that with data.map. I don't think we have to, or do we? We could import it as like data.map. We just import it as a capital M, so we could do m dot and then write the function, right? I suppose, yeah. Type blah maybe integer. Yeah. If you later change all your blahs, it's easier to just change it in one place. Yes and no. I would say that the problems, for me personally, right? This is just for me subjective because I have big problems with names. If you change your types around, that is gonna confuse the fuck out of me and I can't read what's going on. And I would argue if you use like a proper text editor, then changing all of your... Right? If you changed your name of something, right? Changing it just in one place or changing it all over the place, it's a trivial issue. You can just go through your entire file and just change all the instances of whatever you have to another. You don't even have to use Vim for that. You can just do that with sed, right? There are programs that makes those changes trivial for you, right? Do one thing, do it well. So I don't think that programming language has to have that in mind for us, since we can fix that ourselves, I guess. Solburn says, not trivial at all. If you have some places where you want string to be a list of characters, and some places where something else equals a list of character. Incidentally, they're the same underlying type, but different usages. Right, but my question is, right, that's the problem I have. That's my personal subjective thing, right? Why this bothers me is that if you have string is equal to a list of characters, or you can have something else is equal to a list of characters, but they are the same, right? They're functionally the same. The something else is gonna confuse the fuck out of me. And that's for me, right? I understand that not everybody is like that, and for other people it probably makes a lot of sense to do things this way. Yeah. So I'm not... yeah. I suppose having this being part of the language makes a lot of sense. Yeah. I'm not gonna use it though. So it's easier to change string into a list of my characters and not getting confused with something else. Yeah, I wouldn't though. I wouldn't. You're talking about... we're talking about either changing this side or this side. There's a big difference, right? When we replace all of these or all of these. Yeah. And changing all of the stuff on this side, right? List of characters, that would break. Yeah, you do not want to change that. But that's not what we were talking about. We were just talking about the types, right? Changing stuff on this side. And if you have a string or my string or another string, right? This name here is arbitrary. We can put whatever we want in here. But on this side it has to be the same, right? If it's a string, then this is what it is. Solburn says it's easier to change all things you meant to be string rather than also changing things that are some else, which incidentally are a list of characters. Yes, and that's right. That's my point. That's what I'm saying, that to have some else, to have string or some else or any string or whatever, I don't like that at all. I would prefer to just have this. Yeah, this is my string, and this is how we define what a string is in our programming language. That's my preference. And I completely understand that that's probably not most people. Yeah, I'm probably in a very small minority on this side. Maybe obviously even I'm in a small minority. Solburn says this is a simple example. It can be much, much more complex types. Right, but when you have that, that's what I'm saying. If you have a super complex type, why would you have two names for this very complex type? It doesn't make any sense. Why would you have a name and then another name for that complex type? You would just have the one name. Because one name is very simple. Yeah, I'm a simple man. Well, GetInnoTap says, I think synonyms can sometimes make code more readable. Yeah, look at that. Personal preference thing. That's what this all is. Yeah. Right? It even says so, right? Nicer to read. Nicer, that's a subjective value judgment. You might think it's nicer. I might think it's... what's the other thing? Not so nice. There we go. When we were dealing with the data.map module, we first represented a phone book with an AS list before talking about changing the names of things. Yeah, an association list before converting it into a map. As we've already found out, an association list. We had this discussion before with the association lists, right? Yeah, it's a list with key value pairs. Let's look at a phone book that we had, right? We're talking about different languages, calling it dictionaries, maps. What else was it? I don't even remember. Key value pairs. Yeah. A list of key value pairs. I love that name for it. Colgate tab says anti-universe nice? Fused. Right, we have our phone book, which is, yeah, key value. Perfect, okay. We see that the type of phone book is a list of tuples. Yeah, that tells us that it's an association list that maps from strings to, I mean, instead of calling it an association list, we could just call it a list of tuples. And all these extra names makes it just more confusing for someone like me. Alright, Colgate tab says anti-un-inverse nice. Ah, that's what I saw before, yeah. That's the, if it's not nice, then it's anti-un-inverse nice. There we go. Right, that maps from strings to strings, but not much else. Let's make a type synonym to convey some more information in the type declaration. Type phone book. Yeah, so now it's, wait. Alright, so instead what we're doing is replacing, yeah. So it's just gonna say phone book on this declaration line, which I would say is redundant. This example is redundant because phone book returns a phone book. It's like, no shit, does it? Goldburn says NT? I don't know what that means. Source? Trust me, bro. That's the best source. Yeah, trust me, bro. Some random dude on the internet said something. Goldburn says phone book is a specific object name, while phone book is a type. Yeah, this is a type. This is the... Oh, it's an object name. I thought it was the function name. Oh, it doesn't have to be a function. Yeah, I like that. Object name. Yeah, but the argument was... Let's make a synonym to convey some more information in the type declaration. That's the argument. And I'm saying that's not happening here. I'm saying we're obfuscating information. We're taking this information and we're taking it away from the reader. I think when it says phone book, and then this is gone and it says phone book, I think that is less information, not more information. Again, of course, this is just my subjective value judgment, but this whole chapter is just subjective, right? Now the type declaration for our phone book can be, yeah, exactly, phone book. Now we've lost all this info. Well, actually, no, we haven't, because it's right here, isn't it? The information is right here. That information, so we haven't lost or gained any information from doing this. Let's make a type synonym for string as well. Right? Type phone number. Oh. That actually looks a little bit funnier, yeah. A little bit better. Phone book is... And we give names to our keys and values, right? Instead of just calling them string and string. We call them name and phone number. Maybe I have to just concede my point right here. Because that is extra information that we would have to imply as a reader, but when we change this type, we don't have to imply that as a reader anymore. So maybe. Solburn says we're hiding information that the reader doesn't need to know about. It's implementation details. Right. But I would argue that if someone is reading our code, shouldn't they understand our implementation, like what we did? Isn't that the point? Here, right, I know that we have a name and a phone number, sure. But when I only see this, I don't know that it's a key value pair. Here I know it's a key value pair of names and phone numbers. Yeah, like this. Type synonyms for type synonyms, says Tabs. Yeah, all the synonyms, yeah. It's more than just string and string, it's name and phone number, together being a phone book. Yeah, maybe I have to go back on this. Well, I would want to see the implementation still, even though I can understand. Yeah. Could you imagine? Right, we can do this. This looks awful, right? If I do this, this is gonna be awful. Just look at this. Oh yeah, look at this. It's so awful. Oh man, that's awful. Yeah. What the fuck is happening here? What the fuck is happening here? Nobody fucking knows. Maybe, right? Yeah, that shit looks awful. There was a reason I bounced off Perl? The next language. Oh man, I'm terrible in names. That Perl or am I? No, it's not Perl, it's Lisp. There we go. There was a reason I bounced off Lisp. It was too many parentheses. It was just like, what the fuck is going on? Right, yeah. Lisp says NodeRunner. Thank you, NodeRunner, yeah. Alright, so type is phone book. This I like though, yeah. So I would probably prefer, my personal preference would to see this phone book, colon, and then this setup though, yeah. Instead of seeing phone book here, I would want to see this. Right, give the string the type synonyms is something that Haskell programmers do when they want to convey more information about what strings their functions should be used as and what they represent. Yeah, exactly, that is what happens. I suppose we're doing exactly the same thing, that we want to represent our as list as a phone book, because that is what it is. That is what it's used as, and that is what it represents. It is a phone book, it's nothing else. It's supposed to be a phone book. And, right, a trivial matter, right, if I, the confused person I am, like if I run into this name, or if I run into this, and I get confused, a trivial matter for me is to just do backslash and then just search for phone book. And then I will find the type declaration, right? So I can get that information anyway. Oh man, I'm just flipping. Just flip-flopping, right? A few minutes ago, I was like, these type things are awful. And now it's like, no, you have to do it this way. Even though they are problematic for someone like me, yeah. Solburn says you only need to know the interface, yeah. This is how you create one. This is how you add values. This is how you search in it. Right? Yeah. Well, getting tabs is Lisp or Lisp. Lisp. And I really wanted to play around with the next browser. Maybe I'll give it another go. Maybe just work around the parentheses. I don't know. Okay, so now when we implement a function that takes a name and a number and sees if that name and number combination is in our phone book, we can give it a very pretty and descriptive type declaration. In phone book, right? Take a name and a phone number into our phone book, and we return a ball. Holy shit, that is... Yeah, that is pretty good, isn't it? That looks amazing. That looks pretty good. The only problem, right, is that when I call this, we run into a problem because I'm gonna use an integer here. I'm gonna use a num type class here. And then I'll just get an error that says, well, you need to use a string here, not an int. Oh, and then I'll just put quotes in front of my phone number. And problem solved. So that the problem that happens is not really... It's a trivial problem, I suppose. Notrunner says, why don't you go deeper into Surf, like actually try to modifying it? Because I'm a Wayland user, Notrunner, yeah. I would go deeper into Surf. Except that it doesn't work on Wayland, right? I was considering it, but just... maybe not. Goldburn says phone number is obviously a string rather than an int. Is it? Is it obvious that a phone number is a string? I mean, obvious to you maybe, not to me, yeah. I still use string in synonym-less versions, it's called Getting on Tap. Maybe they do, yeah. You know, X-Wayland is a thing. Yeah, but I kind of want to stay away, right? I kind of want to go... I want to use X-Wayland as little as possible. There are no plans to make Surf compatible with... what's its face? With Wayland. Because of plus S and minus S? Oh yeah, if we see them, yeah, but if I don't have, right? In this function, I don't have access to the phone numbers, right? I'm just looking, is this a phone number? Oh, right, you're meaning that, like, the dash doesn't have to be a thing, but the... Well, actually, the plus doesn't have to be a thing either, right? It's equivalent. On your phone, you don't... Well... Yeah, when you have your numpad, you don't have a plus symbol on that. You just plus $00, right? That's the equivalent of plus. You could write a phone number like this, right? 001... 555, 555, 55555, right? That could be the phone number as well. But I suppose, right, why would you want to do that with a phone number? You're not doing maths on a phone number. Yes, you do. I mean, yes, 00, but it's a different number. What do you mean? What's a different number? Might want to canonicalize your number. I don't even know what that means. Canon, I only know about canon that, like, from these books, you have to read these books because these books are the best. Canonicalize means to make it into a standard form. Oh, right, of course it does. Why didn't I know that? Yeah, standardize. It's like having a protocol. This is how you type out a telephone number, because if you type out your... Oh shit, that's the wrong one. If you type out your phone number like this, well, fuck you, dude. How the fuck am I phoning this number? Actually, it doesn't matter. Let's do it this way instead, right? That is awful. Yeah, it's awful. Reading this. So yeah, I would have to concede, yeah. It's obvious that a phone number is a string, when you think about it. So I would say it's not obvious, but when you think about it, a phone number has to be a string. Yeah, I agree with that. Yeah, here we go. String, string. Yeah. Wow, yeah. I've completely changed my mind. I love this. Now, this is how you do things. Right? Make type declarations. Because this looks like shit and this looks amazing. Right, like adding pluses and dashes and adding 0 when needed, exactly, yeah. Not to mention, numbers usually lose their initial... yeah, right? They do indeed. And since it's a pointless digit to have a 0 in front of a number. Not always, but most of the time, right? In this case, the type declaration that took advantage of type synonyms is easier to understand. It is, yeah. Way easier to understand. If you're good at making type declarations. Damn it. However, you shouldn't go overboard with them. We introduce type synonyms... Wait. We introduce type synonyms either to describe what some existing type represents in our function, and thus our type declarations become better documentation. Yeah. Or when something has a long-ish type that is repeated a lot, like, yeah, like this. Yeah. But represents something more specific in the context of functions. Type synonyms can also be parameterized. Yes, that is how you pronounce that word. If you did it in another way, you're clearly mistaken. Yeah. If we want a type that represents an association list, an AS list type, but still want it to be a general so it can use any type as keys and values, we can do this. Missed opportunity, dude. Such a missed opportunity. It's an AS list. We know, right? The author who wrote this book, when doing this example, the first thing that came to his mind was AS list. Then he just chickened out and added the OC. Such a chicken. Because it's obviously an AS list. Yeah. Yeah, Colgatinontab says this should be a list of cares, a list of cares, list of cares, list of cares. Yeah. Into a bool. Without a type declaration, which looks awful. Yeah, it looks awful. Just awful. Right, now a function that gets the value by a key in an association list can have a type of, call it the K, we get the K, then we take an AS list, KW, or why not just KV list, not W, what did I say, W? I don't know. KV list, that would be even a better name for it, right? Rather than an association list, the KV list. Return maybe a value, yeah. AS list is a type constructor that takes two types and produces a concrete type. Like, oh yeah, of course it is. Type constructor. Like AS list int string, for instance. Indeed. Or just AS KV. Let's call it in on tap. No. You don't need the association, right? Oh, actually, I'm a little bit mixed on that, right? Since we have keys and values, semantics of the thing becomes weird. Right, Fonzie says, when I talk about concrete types, I mean like fully applied types like map, int, string. Or if we're dealing with one of them polymorphic functions, right, a list of A's or a maybe A and stuff. And like sometimes me and the boys say that maybe is a type, but we don't mean that because every idiot knows maybe is a type constructor. Every idiot, eh? When I apply an extra type to maybe, like maybe string, then I have a concrete type. You know, values can only have types that are concrete types. So in conclusion, live fast, love hard, and don't let anybody else use your comb. Hey, the fonts. Right. Just like we can partially apply functions to get new functions, we can partially apply type parameters and get new type constructors from them. Okay. Just like we call a function with too few parameters. Ooh, that was a little bit just no. Yeah. That was a little bit too much no. Shouldn't it be I and the boys? I don't know. I would instinctually say me and the boys. But I don't know, like, I don't remember the grammar of the thing. Also, the whole point is Fonzie, right? If something is grammatically off in here, it's by intention, yeah. It's intentional if it is. Because Fonzie is a famous character from years and years and years back from American TV, yeah. Colgate Dinotab says, me say that sounds wrong, but I don't English well. Oh, you missed opportunity. Me don't English well. Oh. Another missed opportunity. Me don't English good. There we go. Alright. We can specify type constructor with too few type parameters and get a partially applied type constructor. If we wanted a type that represents a map from data.map from integers or something, we could either do this type int map v, where we map v, or int map int. Man, this is confusing. Yeah, exactly. That makes sense. Yeah. Nodowner says that my grammar checker says both are right. And of course, I have to, because I always do that when someone says grammar is right, that grammar is not prescriptive, because grammar can't be prescriptive. Because grammar is about studying language and understanding language. It's not about creating language. What came first? The language or the grammar? Of course, the language came first. Then the grammar studied the language. So therefore, just from a meta-linguistics perspective, I suppose. If you go to school and learn a new language and your teacher tells you that is wrong, then yeah, listen to your teacher. Either way, the int map type constructor takes one parameter, and that is the type of what the integers will point to. Nodowner says, but a tool designed to correct your grammar is prescriptive by nature. Yeah, your tool, your grammar checker, is prescriptive. I'm just saying that your grammar checker is, well, like a teacher, I suppose. Just like teacher is prescriptive by nature. It's just like with all the humanistic subjects, take it with a grain of salt. Like maths and programming languages are very straightforward, but when we're talking about natural languages and subjects like that, more philosophical in nature, the word of the teacher and your grammar checker has to be taken with a grain of salt. Because maybe you feel that your way of saying it sounds better than your way of saying it, as long as people understand you, right? Should be the way to say it. Aggressiveness. Wait, what was this? Either way, the intmap type constructor takes one parameter, and that is the type of what the integers will point to. Yeah, exactly. Because map takes two values. We don't have to do that thing. That was another thing that I didn't like this at first, that you remove the V's. Actually, I still don't like it, but I see the value in doing it. But it's obfuscation of information again. But if you understand what's going on, then you understand what's going on, right? Node owners is actually, the more you learn about math, the less straightforward it gets. Oh yeah, it becomes more analytical and more philosophical in nature, right? I wonder, isn't that... that's probably true about all science though, right? The further to the edge you get, you have like... when you learn the basics, it is... oh, that's probably it in all science. That the basics are very straightforward. This is the how the fuck it works. Grammar being the same way then, right? That this is obviously how you do things. This is... we are in agreement, right? This is it. 1 + 1 is 2. First you take the noun and then you take the verb. Yeah. And the further in the complexity and the more you learn about it, the further away you get from the established knowledge, and you move closer and closer to the origin of science, with like maths as well, the origin of maths as well, which is all philosophy at the edges, I suppose, the base of it. Oh yeah, if you're going to try and implement this, you'll probably going to do a qualified import of data.map. When you do a qualified import, type constructors also have been preceded with a module name. So you'd write type in map. Yeah, exactly. Yeah, I remember that. But we would import it not as map.map, but m.map. Yeah. Make sure that you really understand the distinction between the type constructors and value constructors. Alright, value constructors are when we do a data type. Type constructors are just synonyms. Yeah, we just give we give something a different name. Wait. Just because we made a type synonym called intmap or asList doesn't mean that we can do stuff like asList this. All it means is that we can refer to its type by using different names. We can do all of that. That's an asList with int as keys and ints as values. And this seems... Alright, it's just for type declarations. Okay, so when we do a type synonym, they are pretty much just for type declarations, right? Which will make the numbers inside assume that a type of int, but we can still use that list as we would use any normal list that has a pair of integers inside. Yeah. Type synonyms and types generally can only be used in the type portion of Haskell. We're in Haskell's type... Wait. Yeah, exactly, in the type portion. We're in Haskell's type portion whenever we're defining new types. So in data and type declarations. Or when we're located after a double colon. The double colon is in type declaration or in type annotation. Another cool data type that takes two types as its parameters is either a B type. This is roughly how it's defined. Either. Okay. Data type either takes AB. Left A, right B. Deriving check for equality, ord, read, and show. Why left? Because it's literally in the text on the left side or the right side. Either A or B, left, right. It has two value constructors. The left, if the left is used, then its contents are of type A, and if the right is used, then its contents are of type B. So we can use this type to encapsulate a value of one type or another, and then when we get value of type either AB, we usually pattern match on both left and right. And we get different stuff based on which one of them it was. Right 20, we get right 20. Left what? We get left what? And then right A is either a character. Oh, no. Left true, either all B. Oh, right, because... Wait. Either A or a character, because the character is to the right of the A. And the bool is to the left of the B. Yeah. So far, we've seen that maybe A was mostly used to represent the results of computations that would have either failed or not. But sometimes maybe A isn't good enough because nothing doesn't really convey much information other than something has failed. That's cool for function that can fail only one way, or if we are just not interested in how and why they failed. A data.map lookup fails only if the key we're looking for wasn't in the map, so we know exactly what happened. However, when we're interested in how some function failed or why, we usually use the result type of either AB, where A is some sort of type to tell us something about the possible failure, and B is the type of a successful computation. Hence, errors use the left value constructors while results use the right. Huh. I would have guessed you put it the other way around. That A, like the left, the A would be the result and B would be the error, right? If we look through a map or a list, right? We'll look through all of it and then we run into the error. Like, first we check for the result. If we fail to go to the result, then we get the error. That would have been my assumption, yeah. An example, a high school has lockers so that students have some place to put their Guns N' Roses posters. Each locker has a code combination. When a student wants a new locker, they tell the locker supervisor which locker number they want, and he gives them the code. However, if someone is already using that locker, he can't tell them the code for the locker and they have to pick a different one. Indeed, they have to do that. We'll use a map from data.map to represent the lockers. It'll map from locker numbers to a pair of whether the locker is in use or not and the locker code. I was confused. Right, we import data qualify data.map. Right, data locker state, it's taken or free. Yeah, it's either taken or it's free. Deriving show and quality. Alright, we have to be able to compare it to other lockers. No, wait. Right, type code is a string. Type locker map. Right. Map.map. Right, this is the number of the locker, and then we map. Alright, we're gonna have, this is like a nested tuple, right? That's what we end up with. Simple stuff. We introduce a new data type to represent whether a locker is taken or free, and we make a type synonym for the locker code. We also make a type synonym for the type that maps from integers to pairs of lockers, locker state and code. Right, yeah, exactly. So every time we check up, look for a locker with the int x, we get its state and the code. And we know that, right? It's taken, so we don't give the code. It's free, then we give the code. Yeah. Now we're going to make a function that searches for the code in a locker map. We're going to use an either string code type to represent our result, because our lookup can fail in two ways. The locker can be taken, in which case we can't tell the code, or the locker number might not exist at all. If this lookup fails, we're just going to use a string to tell what's happened. Alright, locker lookup. We take an int, we get a locker map from that, and then we either return string or a code. Which is also a string, but it makes more sense, right? Either we define the string ourselves or the code, so we know that we get the code from somewhere else, while the string we will provide as the function designer, writer. Right. And we take, yeah, exactly, we take the locker number and we take the map. Case. I don't remember what case did. How's that different from a guard? I don't remember. Alright, case map lookup. Oh, for every case. Right. For every case of every locker number. Map lookup. Locker number in the map, exactly. Right, and if we return nothing, because lookup might return nothing, then we will say left and we will design our string locker number doesn't exist. Yeah, that makes sense. Or we return just the state and the code, and if the state is not taken, then write code, else left. Alright, locker is already taken, exactly. And good. Time is it? Oh shit, it's time to go. Yep, it's time to go. Right, I kind of wanted to finish this today. We're getting close. Shit, but I gotta go. I've got plans. So we'll have to finish this tomorrow. I'm sorry. Go Lang? No, I have to go. I've got lunch plans. I'm eating lunch with the family. So, yeah. Thanks for hanging out. And, yeah, have a good one. Cheers.